Good evening and welcome to our webinar entitled Beyond the Building, First Year Engineering Makers Community. My name is Jeremy Weaver and I am the Assistant Dean of Advancement at the College of Engineering at Virginia Tech. I want to thank you all for joining us this evening as we are hearing Ben Chambers share his vision and his leadership of our first year engineering student makerspace on campus. A couple of housekeeping items before I turn the program over to our guest speakers. We are monitoring the chat on YouTube and we'll feature time at the end of today's presentation for Ben to have a Q&A session following his planned talk. Please feel free to submit questions at any point during the program and we'll add them to the list to be discussed. We also will promise to wrap up by 8 p.m. Eastern Time so you can all get back to your regular evening activities. Now, it's my honor to introduce our department head for engineering education at the college, Jenny Case. She will serve as the introduction for our program this evening. Looking forward to hearing her provide a little bit more background information about the first year experience for our engineering students, and then she will introduce Ben. Jenny, thank you for being with us tonight.
Thank you, Jeremy. It's my great delight to be here tonight to introduce our speaker, Dr. Ben Chambers, who's an Associate Professor of Practice in my department, the Department of Engineering Education at Virginia Tech. But before I introduce Ben, I want to say a few things about the first year engineering student experience at Virginia Tech. This is an incredible community to be part of. You will be one of over 2,000 students who have been selected into the general engineering program at Virginia Tech. Everyone comes in through this program, and there are really significant advantages to how we do things here. You will be part of this large, energetic, lively, and interesting group of young people who come from across Virginia and well beyond. But you also have a number of experiences that will help you build strong networks of peers who will support and encourage you, and you will get individualized attention both in academic and career advising, and also in our classes. We will work hard with you during your first year to help you make the best possible choice you can of an engineering major. About half of the students who enter our program actually end up choosing a major different to the one they thought they would do when they came here. You have incredible options here. Many you might not even know about yet. That's fine. Everyone makes a better choice than they would have at the start. A defining feature of your time doing engineering at Virginia Tech will be all about hands-on engineering experiences. Whether in a multidisciplinary design team, making a human-powered submarine, or in an undergraduate research laboratory designing drones to get medication to rural communities, but you will start your hands-on experiences, all of you will, with us during your first year as part of our Frith community. Frith is a makerspace, but it is also a community of makers. And there's no better person than to tell you more about Frith than Dr. Ben Chambers, our keynote speaker this evening. Dr. Ben Chambers is an interdisciplinary scholar and an associate professor of practice in engineering education. It was my great delight to recruit him into this role in 2019, following 2 stellar years as an instructor in our program. Ben is also a 3-time Hokie with, wait for it, 2 master's degrees, 1 in civil engineering and 1 in entomology, and put it together, a PhD in environmental design and planning. I hope he's going to tell you about his research, at least a bit, about his research on stink bugs and how they enjoy human habitats. His educational research includes student creativity and expression, as well as the built environment as an educational tool for engineering, biology, and ecology. He has a strong and growing record of publications and grants. Ben teaches classes as part of the first-year experience. Even more, he connects with each and every first-year engineering student at Virginia Tech in his role as director of the Frith First-Year Makerspace. We're really excited to have Ben talking with you tonight about the space, how it is used to provide our students with experiential learning going past the classroom, and how failure is used as a teaching tool through projects in the space. And so now I'll turn it over to you, Ben. Off you go.
All right, thank you. Everything's set up, it looks like. Cool. Well, thanks for coming tonight. I was very excited to be asked to talk to you, and doubly so when they told me who was coming. So our audience is a before and after picture of Virginia Tech engineering. We have a lot of prospective students watching this and a lot of engineering alumni. So if you're new, I hope that this inspires you to join our community. And if you've already been through, then I hope that you are inspired to see the next generation. So tonight, I'll talk a bit about the First Year Makers program and the community that is formed around it, and show off a little bit of what we do and what we have planned for the future. Per the title, we are going beyond the building, but let's start with the building, good old Randolph Hall. So I expect the alumni in the audience will remember it. And the history of the Frith First-Year Makers starts in 1999 with the establishment of the lab. Now, the vision here was to have a space and an opportunity dedicated specifically to providing our students with a hands-on engineering experience in their first year here. Since then, we have lived in the basement of Randolph Hall with a lab just for making things. We have storage space and an additional room upstairs that was formerly a teacher break room that's now filled to the brim with 3D printers. We also manage and supply tools and materials to all of the classrooms that our program uses over in Goodwin Hall, where a lot of initial prototyping and build work begins. We have a lot of equipment available also. We have the standard complement of hand and power tools, but we also have a lot of other stuff like an electronics and soldering station, laser cutters, 3D printers, routers, and a variety of specialty tools. Now, we have also more recently added a few new things like a bandsaw, a vinyl cutter, and an industrial sewing machine. And we have a nice long wish list for when we have more space. And just as empowering to the students is that we stock a variety of materials to use in the space, freely available to the students, which makes it more accessible to those who might have trouble getting a hold of materials for financial or logistical reasons. Now, all of this is provided to support new engineering students. Now, we live and breathe that. The Department of Engineering Education is the home of the First Year Engineering program. And while teaching engineering is at the core of my mission, we are also well known for our research into how to do it better. So if you've already graduated, you may remember coming into work on projects for your first engineering classes. They've changed over the years as we do continuously seek improvement, but hands-on design is always an important part of the experience. And we actively create opportunities for students to get that experience of making things. But while us faculty, we can create opportunities, it's really the students that make things happen. As soon as the space was established, the students started making things of their own. Now, you alumni may remember talking, encouraging each other, brainstorming, and building your ideas. And it was fun. And engineering became a part of who you are. And with that common interest, space, and activity, you came together. Now, our work is based around building, which leads to being supportive. When you make things, especially for the first time, a lot can go wrong, and it will. And when you're working together in a space, you can't really hide that, but you can show it off and laugh about it and talk about it with each other and get new ideas for how to do things better the next time. And that brings everybody closer together. So it's our students then that make this more than just a makerspace. They make it a makers community. This is a big community. And we serve all of the first-year engineering students at Tech, and we have a lot. This year's class is about 2,400, and we will be growing as in future years. So this is important to understand in seeing how we build this community and this program. Our students come from a range of backgrounds. Some of them have already been in professional roles. Some have come from well-equipped shops at home or in high school. Nick Bedard, who manages our lab operations, was actually handed a welding torch when he walked in as a freshman in high school. But just the other day in the lab, I was talking to a student that was working on a project who had never really had access to this kind of stuff before. He said that he would have had to drive an hour out of his way just to get hold of a workshop. And now I see that student in there every week working on cool projects to give to his friends and to his family. And that is exactly what I love to see. Students coming in for class and then keeping on coming in. And sometimes we get lucky and we're able to hire them. And that is how we're able to actually run the program. So we have some faculty and staff support, of course, but the backbone of our makers community is the undergraduate lab assistants, or the ULAs. They make everything possible. Now, we currently employ around 30 students in this role each semester, working 4 to 8 hours per week. Now, some start in their first year, and most will stay until they graduate. And the ULAs, they stay because they love it. We encourage them to build personal projects, to develop their engineering and creative thinking skills, and also to inspire the new students that come in that see what's going on. Now, that's not where it ends, though, as many of the ULAs will tell you about how meaningful their experiences of teaching and mentoring new makers in the community are, and how they feel about paying forward their own experiences being taught by ULAs when they first came in. And every one of them will gleefully tell you about their catastrophic failures making things. So, making something amazing takes work, and working past a lot of big mistakes. The ULAs, they form a core of friendly, knowledgeable, and engaged engineering students. They all exemplify the kind of open community that we have. And nobody shows that more than Nick Bedard, who, after 4 years as a ULA, came back to manage our operations. Even when he sleeps, he's dreaming about makerspaces. Now, I invited Nick to record a short video talking about that experience, which I will play for you now.
I'm Nick Bedard, and I'm the assistant manager of the Frith Lab here at Tech. I got my start involved in the lab just about 5 years ago during my first semester here as a student. While I was here in my first semester, I was looking for a space that I could work with my hands and try and sort of unpack problems and just get a better feel for how the world worked around me. And through that search, I came to the Frith Lab because it was just about the only place that I could find that allowed freshmen like myself to work in their space. I quickly found tooling that made me feel right at home, and also equipment that I had never had exposure to because it was more industry standards equipment rather than just your average hobbyist. Frith became the place that I like to spend most of my time, and it wasn't just because of the workshop that we had. Most of the reason why I wanted to come back to Frith was because of the community of ULAs that we had there that were always eager to answer any question that I could come up with. Between my curiosity and their willingness to answer, I quickly found myself at home amongst those ULAs, and I became a ULA myself my second semester here at Tech. It was now those senior ULAs who were helping me teach the incoming freshmen the hows and whys of the way we do things. As a ULA, I got the opportunity to work with students on awesome projects like autonomous robotic violins, all the way down to just leatherworking, keychains, and other little trinkets that students want to bring home to their families. We also got to answer questions like, why isn't my circuit working? All the way down to how do we put out this fire in the laser cutter? All the while stoking that same curiosity that I had coming in the first place. Now that I've transitioned into my role working on the management of the space, my goal is to stoke that same curiosity and that same passion for our students amongst the ULA staff. We know here at Frith that labs are recognized for the high quality prototypes that they put out, but we know the way that we make those are by screwing up the first four. We're as excited as ever to see the projects that our students put out and the journey that it took them to get there. Thank you.
There we go. All right. Thank you, Nick. I love seeing that. This is a fantastic team we have, and I am thrilled every time I come in. We are all here to make things possible for the students. And what's possible is an endless source of amazement to me. I'll start off with course projects. And we currently run a 2-semester sequence, with the first semester mostly about understanding problems, but we like to get students into the space making stuff early. So when I teach the first semester course, I send my students to the lab to make their own small projects as part of a make something sequence. Students build all sorts of stuff, from dorm room furniture and decorations, which are very popular, on down to gifts and jewelry for their family and other loved ones, which is on everybody's mind this type of year. But the real heavy duty work comes in the second semester, when students do a big design project as a team. A variety of themes have been used over the years, including UAV design, aesthetic wind turbines, RC car attachments to move objects around, and my personal favorite, which is musical instruments. Now, I have facilitated that for the first time this semester, and there have been some awesome designs coming out of that, like a xylophone piano and some totally new instruments that I will be building for myself soon, like a slide drum and a sort of a kazoo horn. But our community is about more than just the class. So we also hold build events where students can come in and work on a short, accessible, and low skill project designed usually by ULAs or graduate students. These events get students in the door, comfortable with the space, and looking around at all of the possibilities. So far, we've done pendulum painting, pop-up greeting cards, stickers, and jewelry. And every student that I've talked to walking out afterwards has asked about coming back for their own projects. So we have more currently in development. So new students can watch out for things like racing hovercrafts made out of trash. All that takes is a Ziploc bag, a motor, and some cardboard. Ultimately, our community is about self-expression, though, and development as engineers. We have a long history of students working on their own things. There's plenty of simple but beautiful laser cutting and engraving, such as coasters, but it goes on to complex builds like this light up Catan board that ULA Mel made. The laser cutters and 3D printers are popular. You can do a lot with them. We also have some really cool stuff that happens when you add in the electronics and controllers and LEDs and a little bit of inspiration. There's a little video made by ULA Travis of some decorations that he made for his own home. A spoon, a bowl, a sign, and this really cool wall hanging that actually changes colors. Now, these are all great and beautiful, but I do want to point out again to all the prospective students in the room that we do mess up a lot. I introduced this in class by asking students, what have you screwed up lately? And most of them like to start with talking about how they've not studied enough for a test, but then we get to talking about how messing up is a huge part of learning how to make things. Design is iterative. We try, we fail, and we try again. And our lab is decorated with all sorts of botched designs. We play with this failed 3D print of a lattice vase on the left there, and we look at the remains of messed up laser cuts all of the time. My favorite is this burnt out bit of wood that sits by the router. It looks bad. It's actually an intentional burn test, but it catches the attention and it's fun to talk about. It shows you that things can and do go wrong, and that when they do, the whole building isn't necessarily going to go up in smoke. And the important takeaway there is also that it's a safe place to screw up, not least because we do focus on safety and wear the appropriate gear. There are safety goggles by the door for everybody. That is a lot of cool stuff already going on, but our research and our experience teach us more about effective engineering education every year, and our program continues to grow in size. We're also preparing to move in a few years as Randolph Hall is demolished and the new Mitchell Hall is built, which is planned to contain a new space for the first-year engineering students. We're constantly making new developments to keep up, and we want a future where our students can do more of everything and anything they want to. For instance, this semester, we've been making new kinds of projects. We've got stickers coming out of the vinyl cutter and Halloween costumes and handbags in the industrial sewing machine. We're also adding features to the lab that were designed and built in-house. You can see here a safety cutoff for our miter saw that was installed a few years ago. We also had a graduate student this summer build powerful movable air filters to help mitigate dust and fumes. Dust and fumes. And Nick Bedard has been working on a prototype of a system for verification of student training and management of access to our heavy-duty equipment. It's currently in place on our bandsaw. And we're also saving money on student materials by processing bulk items with the use of that bandsaw. We're also expanding our community to include new partnerships. Engineering major exploration is an important part of the first-year experience, and so we are working with departments to create new build events. Most recently, we've initiated a collaboration with mining engineering to design themed kits to assemble models of mining equipment. We also, this year, have a senior design team from the Industrial and Systems Engineering program working on our inventory management system. And they have already made some tools that significantly improve our purchasing process. We hope to get more teams in there like that so that our first-year students can talk directly with them and learn more about their major options. The Makers community also supports undergraduate research programs for first-year students, where they work on a wide variety of technical projects with several faculty, including my own team of students who are playing with bugs, as Dr. Case mentioned before, primarily stink bugs getting in your house, but it's not just that. But we're also going to launch a new project next semester where students will be working on systems that make fuel out of kitchen scraps. And along with that, we're engaging with faculty and graduate student researchers who are interested in the role of maker spaces in engineering education. Our current graduate assistants are laying the groundwork for this, and faculty in the department are in the initial phases of developing some research proposals. The leadership and learning opportunities provided by the ULA program are already great, but there's plenty of room to grow, particularly as the student population grows and we move into new spaces. In addition to the work in managing the space and creating new students, we're exploring new types of lab assistants focused on things like creating and running build events, connecting with majors, and learning more about leadership. We've actually piloted the first new classification of ULA this semester focused on communications. This ULA, Annie Hunter, has worked with our department's director of communications, Nikki Hazuda, to create all kinds of maker-related content to inspire more students to come join our community. It's worked well, and we will be expanding the role next semester. All right. So we are constantly farming new ideas, and we have an open culture of suggestions from ULAs and students and anyone around who's involved in the community. We thrive on experimentation, and we will always try new things. We're not afraid of things going too wrong. That is part of the process, and if we're lucky, a failure gives us a good story. So, If you're interested in joining the community or just looking for inspiration, follow us. We have an active and growing web presence, but most of all, keep your eyes open for cool new things and keep on making your own. Thank you. All right.
Perfect, Ben. We're now going to transition over to the part where we'll do a little bit of Q&A based on your presentation. And we've had some good questions that have come up in the chat. And I guess let's start off with one of the basic ones to say, what do I have to do before going to and using the Frith Lab?
Oh boy. Yeah, so we have safety rules in place. So if you are coming in as a student, you will have to take a couple of safety training courses online and read and understand and agree with our lab safety policies. So once you've done that, you can come in and swipe your ID card, which will pop up in our system showing, hey, you've got all your training done and you can come on in. Some equipment requires additional training, and we do have signups for that. A good deal of that is done online, but we do have some additional steps for some pieces of equipment that you have to go through in place to make sure that we're happy that you are gonna behave safely.
Fair enough. Sounds responsible too. So why is the Frith Lab designed specifically for first-year engineering students? And how does it fit into the curriculum of the first year?
Oh boy. Okay. Well, a lot of reasons for that. So first off, we like to have a space for students to really engage in engineering very early on. So that helps with connecting with the major and increasing retention. So if you are coming in and you're not really sure what you want to do, and you're feeling a little alienated from the community, then you walk into a space like this where we're encouraging you to make things, then you start becoming part of it. So that's a big part of why we have this space for the first years. Specifically how it works into the curriculum, though, is that predominantly in that second semester course, there is a semester-long design project where students will work as a team on a particular design goal. And you have to go into the lab a bunch over the course of that semester to work on multiple iterations of your prototype for your design to get a feel for how to do things and actually make it. So we also do some of that in the classroom because of the size of our program and the limited size of the lab, but everybody just about that comes through the program is going to need to be in there a lot during their second semester. And some instructors like myself do also send students into the lab as part of the first semester for build projects or other activities to help them engage with the program.
Answer. So I'll throw you another softball this time. So we'll go back and forth on them.
All right.
But tell me, how and when do prospective ULAs apply, and how do they get selected? Are there certain criteria that they must meet to get that responsibility?
Well, a key word there is responsibility, right? So you're working in a space with a bunch of students who are working with tools that, you know, that need to be used correctly, right? So there has to be some sense that you are a responsible person. So a lot of our ULAs are drawn from students that come in to work on personal projects, and our staff will talk with them a lot because they're in there a lot. They get a sense of who they are and whether they're going to behave responsibly and engage with the students that come in. So that is a big part of where we get our people from. So once you've become part of the lab, you may very well find yourself staying if you wish to. But we also put out invitations for students throughout the university to meet our needs, particularly in engineering. So it's not just people that have been in there.
Okay, continuing on the responsibilities, do students have access to all the machines? The question's about 3D printers, but let's just say, are there things that some students aren't allowed to use, or once you're in there and trained?
So some equipment has additional training requirements for it. So you might not be able to use, the bandsaw until you have, or the router, or the 3D printers, or the laser cutters, until you've gone through some additional training beyond just the baseline stuff and demonstrate that you know how to operate it safely. But there is no equipment that is completely off limit to students.
Okay, that's good. There was a lot of detail talking about woodworking. What type of metal manufacturing might be there, or what would be other materials that people might use?
Okay, so a lot of the metal working fantasies that we have, we're not in a position to do right yet, but we do have some. We are planning to get some additional manufacturing capabilities for metal starting pretty soon. We've got some equipment that's on order that is not in place yet, but we all do have some basic stuff for shaping. We have an anvil, for instance, that has been used for a variety of projects, particularly in jewelry, that is a lot of fun to play with. We also have, some basic tools. So we do have some sheet. We have a mechanism for shaping and bending sheet metal that does get used to make some boxes and some things like that. And of course, some regular cutting equipment. So there is some metalworking that goes on in there. We also have this funky device. It's an Instron. It's used for compression and tension testing that some of you that may have already followed us on Instagram may have seen the crushing videos of pumpkins and such like over the course of last summer and this fall that we're looking into the possibility of using to stamp some very soft metal with.
Pretty cool. So are the materials provided to the students, or do they have to bring it themselves?
We do provide a lot of materials to students, but not everything you could possibly use. But we do have a variety of wood and acrylic pieces that are available for laser cutting and engraving. We have lots of scrap wood. We have some scrap bits of pipe. We do like to keep PVC on hand. We do have a variety of electronics components that are available for students to play with, wiring stuff. So yes, there are a lot of materials, but if you want something specialized, you may have to go out and find it yourself.
Okay. So when I'm there, if I were the student, are there different, I'll say, thrust areas that you can take? Could I focus on electronics, or could I focus on the material side of things? Or is it pretty much going to be everybody does the same thing?
No, I mean, there's a wide variety of materials, and everybody's got and equipment, and everybody's got their favorites. If you're a ULA, we do ask that you gain a high degree of proficiency with everything. So we'll assign you projects to play with, so you make sure you understand how to show someone else how to use it. But if you're just a student coming in to work on something, you might be really into electronics and spend all of your time at the soldering station, or you might just be really fixated on intricate laser cut wood kits. You can do what you want to do.
And let me rephrase that question.
Oh, okay.
I'm aware there are other maker spaces on campus. The library has some, the living learning communities have some. This isn't the only space, right?
Correct. It's the only space that's dedicated to all first-year engineering students. Now, as you said, the living learning community is a space for engineering students in that community in the first year specifically to use. But everything else is either accessed in a different way or limited or or not specifically for the first years. And I think this was a question at the very beginning there, a little bit about why we have this dedicated space for the first years. And anybody who's walked into a space with a bunch of your seniors can attest, I think, that if you're the new person, it's sometimes easy to get pushed out of the way and taken over by someone who's more familiar with the space. So that is why we provide this. Part of why we provide this.
That's helpful. Could you describe maybe a couple examples of the most creative? I'll use that word, but you can define what creative might be coming out of the Frith Lab, or maybe what is the epic fail of all failures?
Oh boy. So I don't want to call any favorites. Some, I've been in this program for 5 years, looking at just incredible stuff, and the most impressive creative thing is usually just the latest thing that I saw. If I'm being honest, I remember first seeing a student making an electric cello for one of my courses a few years ago, and just being, that's fantastic. More recently, the pop-out example is that Settlers of Catan board that ULA made. I was watching her prototype it, and there were these different little smaller versions of it where she was playing with the microcontrollers and the wiring of the LEDs and getting the lighting to show up. It was a really complex project, and it really kind of exemplified the engineering process in art. And of course, that's not far from the only one that I've seen this semester. A few other ones have showed up in this slide presentation that I gave before. Yeah, it's always amazing.
And that epic fail?
Epic failure. It's hard to call it that. It's hard to call it that because I saw, well, okay, let's talk about this then. Stuff burning in the laser cutters, that's usually the most standout piece. You try 16 different ways of trying different equipment and different materials in there, and you get it wrong every time. I've done this myself, running in the laser cutter. Someone brought in a different type of material, some hardboard, and they were trying to figure out, what the right settings were for it. And there was some glue in there that really smoked up the machine. So we had to do a lot of extra cleaning for it. And we figured out the settings eventually, but it was quite a lot of work to get that sorted out.
Fair enough. And I won't ask whether or not the Blacksburg Fire Department's ever appeared at the lab. So you came in the introduction, you said 2,400 students. We know that almost all first-year students go through this. So what is it like when the lab is in full swing? What are the hours you're running? What's the hum feel like in the Frith Lab?
Boy, howdy. So it's some of it is dependent upon the rhythms of student life. Courses are often set at particular times. A lot more students might be taking courses during the day than in the evening, but we are open usually 9 or 10 hours a day every day on the weekdays, and 5 or 6 on the weekends. There'll be more in the spring semesters when we have more students coming in. Every time I go in at night or in the evening, particularly around deadline times, the place is hopping. There can be a line out the door, particularly in the spring semester. People just waiting to get in there and get started going. But there's always someone in there working on some kind of project.
Okay. This goes back to cool projects, but maybe this wasn't necessarily truly innovative in what they did. But do you have a favorite aha moment where you saw that light click on for students, or is there a common project, I guess, where all of a sudden I get that, I understand that, I see why you're making me do this?
Yeah. Okay. So here's a fun example based on one of the course projects, which is the aesthetic wind turbine. So in that project, the students have to build the blades on a vertical axis wind turbine. So it's spinning around this way rather than the ones you've seen on the skyline, which are a horizontal axis. But the first thing that students do oftentimes when they're testing that out is they build symmetrical blades. So there's not this differential in pressure of the wind on the blades, and so it doesn't actually spin. So it's always fun to watch them realize that they got out a little bit of asymmetry, a little in the way you're looking at it directly. There's got to be a little cup in there, a little difference in how the wind hits it, and so that gets them really starting to think about the physical systems that their designs are working in.
That's exactly the answer I guess I was looking for. Didn't have it in my head, but you provided the sample from that. Is Frith Lab open for students to come see when they're on campus touring?
So if it's not too crowded, we certainly invite people to poke their heads in and look around. Absolutely. We want to encourage you to come here. So as long as it's open, you can come and knock on the door and say, "Hey, I'm a visiting student. I just wanted to see what's going on. Can you tell me a little bit about the space?" And a ULA or whomever else is there working there will be happy to tell you a little bit. We won't let you use any equipment until you've actually taken the safety training, but absolutely we would welcome people who are curious about it. We will also, I believe, have some scheduled times if you're working with the tour groups and whatnot that come through too. So,
okay, that's awesome. I have somebody asking about the capacity and how big it is.
So currently we limit it to 55 seats at a given time for safety reasons. So it is this one room there in the basement. So if you get any more than that in there, then there's not space to move around. And so we want to make sure everybody can get out if need be.
Fair enough. I'm going to throw this out there and show my ignorance for a moment. Are most projects built and planned in SolidWorks first?
Well, I would say that in this moment they are, at least if they're using something that requires a 3D model, like a 3D printing, a 3D printer, because SolidWorks is the software that we use in our courses and make sure that everybody has a basic level of proficiency in. But everybody, particularly if they've learned it before they come to see us, has an opinion about what the best software is.
I bet they do. That's awesome. And I presume, correct me, that individuals that create something are allowed to keep them after completion?
Oh, yeah. Absolutely. If we kept every creation you made, then, well, you wouldn't be able to walk in the door. Now we do invite students. We have a Polaroid actually. So we've been inviting students to take photos of the things they've made and post them on the wall or on the front desk. So we have a little bit of a record of what goes on. But yeah, take it with you, give it to somebody, make somebody's day. That's fantastic. That's what we want to see.
Okay, that's good. And just to follow up on the software, we did get questions of use of Autodesk Inventor or AutoCAD. Mm-hmm. Are there other software packages that are available, or is it pretty much just sticking with the SolidWorks?
Oh, no, you can do all kinds of things. Depending on what equipment you're working with. I mean, if I'm doing laser cutter, I usually use something open source like Inkscape or GIMP, but that's two-dimensional vector drawing. I have students that like, what is it, Rhino and Blender. There's just all manner of programs that you can use if you want to. We just don't necessarily have a ULA that knows how to use it if it's something unusual. So.
Do you see working in the lab that some of the student experiences help influence what particular program they might go to? And since everybody comes in general engineering, I mean, does Frith Lab really change or influence what people do?
If you let it, absolutely. Absolutely. So there's a lot of students that come in thinking, about how much they want to do hands-on work. Many of them still do after the program, but some of them decide that that's not what they want to do, and they'll go on a different direction. Maybe they'll focus on computer science, for instance. But that kind of exploration of all these different kind of tools, I've had students talk about how they wanted to shift in material science after they've been playing with metal or doing something in like the vacuum sealer. We also have students that decide they want to start working in electronics after they build some kind of neat little showy thing, or playing around with lightsabers. We have students that build lightsabers. There's all kinds of cool stuff going on that inspires students to go in some new direction.
Now, is the lab open if I wanted to maybe create something that was not necessarily project oriented for the course? Could I go in there and just work on a personal project?
Absolutely. And yes, please. And the course projects are happening on a particular timeline, of course, but you want to get in there all the time and get working and learning about engineering. This is becoming an engineer is about a lot more than class, and we do very much focus on providing a space for you to learn in the ways that you think are most relevant and interesting to you. So we strongly encourage personal projects.
So what is the most outlandish thing, the craziest thing you've seen somebody pull out of the place, either for a project or on their own?
There's all kinds of cool stuff that comes out of students.
Not a time to drink coffee, Ben.
Yeah. My favorites are often, music related, just because that's what speaks to me. It hadn't occurred to me that, you could manufacture, a lightsaber and play with that, making cool noises and pressing buttons and all of that. That was pretty neat. I gotta say, I was thrilled by that. I also, you ever played with a theremin? It's an electronic instrument it's played by moving your hands closer and further away from the instrument itself. They use them for that old kind of sci-fi music from like the 1950s music or movies, excuse me. That was cool.
For those that are fans, a little drum and space instrument. Okay, so are there always staff members or students available when the lab's open for the assistance on the equipment?
Absolutely, yes. If we don't have ULAs, then the lab isn't open. That's kind of crucial. So yes, we try to have at least 3 in there at any given time.
Okay. Someone's noticed, surprisingly, that it seems like you enjoy your job. So what's the favorite thing about being the director of the Frith Lab. What gets you out of bed in the morning?
Um, wow. Yeah. I mean, seeing students build new things that I was not expecting them to see. You know, I go in there and there's this beautiful sideboard that or wall hanging that someone's made with all these fancy LEDs. They've got or maybe they've got a new sign that they're making to show off their band, you know, like to take to their band's shows. Maybe there's someone, like I said, making lightsabers. There's these pop-up cards. There are these intricate machines that are building stuff. And then there's students that go in and build stuff that improves the lab itself, like those air filters that I mentioned before. It's just really exciting to see something new every day, and to get ideas for me to make stuff myself too. So
that actually is a really good segue, because as our final question, let's get away a little bit from Frith and talk about some of the research that Jenny mentioned you actually do, and tell us a little bit about what you're doing.
With respect to creativity in the makerspaces, yeah. So what I've been doing thus far, what I've put out in the world thus far, I should say, is related to the kinds of stuff that students do when they're given free rein to design whatever they want at this stage in their academic career, right? So I presented a conference paper this summer that was looking specifically at the planning phases, you know, and how students think through how they're going to actually approach the design problem. You know, like, do they have a realistic idea of how much time something is going to take, and what kind of stuff they're going to need? What is inspiring them? What is getting them interested? What do they actually want to do? We're also working on some stuff that's in development right now, that we're going to be looking specifically at the experience of the lab assistants, and how they interact with the students, and how that informs their development as engineers. So a little bit of the actual creativity stuff, and a little bit of the personal and community stuff. So yeah.
Really nice. I appreciate you sharing that information from that background. And I want to say thanks on behalf of the college for what you're doing here and taking the time this evening to spend with us. I also want to thank Jenny, and I'd be remiss if I didn't thank Ray and Violet Frith for their ongoing philanthropy to help support this lab. And for anyone that is interested, Ben noted earlier in his conversation that there will be a replacement of Randolph Hall, the name Mitchell Hall, and the donors for that were announced yesterday by the university. And so you could go on any social media or even the university or college webpage and learn more about the gift by Wendy and Norris Mitchell. That building is still under the planning phases, but it will radically change what we have and the next generation of space for our students in the maker community. With that said, thank you everyone for joining us live, and those of you that are watching this recording, please stay tuned for future programming that we're offering. You can send questions to vtengalumni@vt.edu. That would be Angela Mills that'll answer that. If she doesn't know the answer, we'll find somebody who can. Once again, that's vtengalumni@vt.edu. Thanks again to everybody. Hope you and your families continue to stay safe and healthy, and we look forward to connecting in future programs. Appreciate it, everyone.
Thank you all.